All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. Just making up this quick video here to show those who are going to be on the choir trip tomorrow how to do some of the problems that we'll be looking at. Now, as we move into what we're getting into, you guys have noticed over the course of this entire chapter, we've really been focusing on proving things, okay? Proving triangles congruent, making sure there are justifications align with our statements, and making sure that things logically flow together, okay? And so we're going to continue that same pattern here as we look at section 4.7, but we're going to do something a little bit different. Now, up until this point in the year, you guys, well, up until this point I'll say just in math in general, you guys have been working with the coordinate plane, and you know how to identify a point on the coordinate plane. So for example, if I go ahead and say, if I have a coordinate plane, graph 1, 2. 1, 2, got the point, there's my point, 1, 2, okay? And that's really simple. But in a proof, we don't want to use numbers because they're constricted. They're not fluid. They're not able to be moved around and have the same meaning take place. So as I look at a coordinate proof, we may assign a value for a certain point, let's say A, comma B, okay? Well, what does that mean? Well, both are positive values, and so we know it's going to be in the first quadrant, okay? That's the first thing I'd look at. The second thing is this. This point is going to be over A units. Now, I don't know how far A units is. It can be different for different problems, but let's say that this is 8 units over. It's the x value. It's how far I travel on the x-axis. The b value is the y value, so maybe it's only up that far. Okay, that would be b units there. That's how far we're traveling on the y-axis. So to get to this point right here, we're going to go over A and up B, and that's how you get the ordered pair A, comma B. Okay, that's what that means. If I were to go ahead and say something like negative A, comma B, well, that would be this. It would be to the left of the origin, A units, but it's in the negative direction, and then up B. So, for example, this could be negative AB. All right? So we're replacing numbers with variables, okay? Because variables aren't as constricted, they're not as confined as numbers are. Numbers, you have to say, this is where it has to be. Where variables, we can plug in different numbers there, but what we're about to observe would still have to be true. So let's go ahead and take a look at this first example here. What we're starting with is making sure that we understand how to put figures in the coordinate plane, okay? And so as I look at number 1, it says this: position and label a right triangle MNP on the coordinate plane so that leg MN is A units long and leg NP is B units long, okay? So let's see here. Let me go ahead and draw out a coordinate plane. Okay, since both are positive, we could actually put them in any of the quadrants here. But usually we see it's going to be in the first quadrant, or that it's going to be centered on the y-axis. Now I'll point that out in the next one. So if I have a right triangle, MN is A units long and NP is B units long, I'm going to go ahead and do this. Let's go ahead and put M here. N will be here. And then P will be out here. Okay? And so that way, when I draw on my right triangle, this triangle right here, okay, we have a leg NP right there. We have a leg MN right there. And now we want to figure out their ordered pairs. Now let's start with the easiest one. The easiest one is N, and that's at 0, 0. Okay, that was simple, not hard at all. Okay. Now, as far as the ordered pairs for N or M and P, these two here, let's go ahead and do this. Since the length of MN is A units, let's go ahead and show this as an A. okay? And so the ordered pair for m, if this is a units up, now that's the y value, right? It's up a units. So the y value would be a, and I'm not going anywhere on the x-axis, it would be 0, okay? Now if you're having a hard time seeing this or understanding that, here's what I want you to think about. Think of this as a number. Let's say that this is 3. If I want to identify this point, wouldn't it be 0, 3? The same thing is true with the variable. It's just going to be 0a, okay? Since NP is b units long, I'm going to put b right here. And so the ordered pair for this one, b is the x value, right? So the x value is b. And the y value, it doesn't go anywhere on the y-axis, up or down. So therefore it's 0, b 0, okay? Now I think a logical question at this point would be this. I get the lengths, I get the ordered pairs, but how do I know that NP is here and MN is there, okay? Technically they could be switched. If you went ahead and drew this, I wouldn't be able to fault you. N, P, M, okay? And so if you said, again, this would be 0, 0, makes sense. This is a length of A, so this is going to change. Instead of being 0A like it is up here, it'll be A0. And then this length here will be a length of B, so instead of having B0 here, it's going to be 0B, okay? So I wouldn't be able to fault you if you did that. It means the same thing. The key to this problem is this, and I mentioned it a moment ago. Most of your objects are going to have a vertex at the origin, okay? Unless it states something otherwise, and you're going to see that in number 2. So you want to try to place them at the origin. It makes it simpler in figuring out the ordered pairs. Now, I was just thinking about this. You can actually do this in a third way. Let me show you a third way you could do this. Position and label right triangle MMP on the coordinate plane so that the ligament. Yeah, so you could do this. This would also be acceptable. Okay, I guess there's several different ways that I was thinking about it. Let's say that this is M. Let's say this is N. And that this is P. You've got leg, leg, hypotenuse. Okay? Now, this time M would be at 0, 0. N, since this length is A units away, is going to be A0. Okay? Because it's the x value, right? And then since this is b units up, now this gets a little bit tricky here. I'm going to go to that point right there. So this is over a and up b. The ordered pair would be a comma b. Okay? So that would also work for that one. Yeah, I think that's about as complicated as you want to get there for that one. I guess you could switch n over to this side and have it go this way. Still remain the same, but if n were over here, it would be 0, comma a, because we're going up a units there. Okay? So I hope you're picking up on this as far as where the values go. What's the a and what's the b? When I look at the next one, position and label the isosceles triangle JKL on the coordinate plane so that its base, JL, is a units long. The vertex K is on the y-axis, and the height of the triangle is b units. So, unlike the last one, I'm pretty sure that this one only has one way that you can go ahead and draw this out. So I'm going to go ahead and do that there. Now, we want the vertex K on the y-axis, so I'm going to put this here, K. Okay. JL is a units long. Yeah. The easiest way to draw this is actually centering the isosceles triangle on the y-axis here. Okay. So this is going to be J, and this is going to be L. And what we know is that these lengths are the exact same. Okay. Now, one of the things that we can talk about here is this. that when you have a segment that goes right down the center, so this is going to form a right angle down here, okay? What this forms is two congruent triangles by hypotenuse leg, okay? And the reason why I'm bringing that up is because if these two triangles are congruent by hypotenuse leg, then this segment here has to be congruent to this segment over here by CP CTC. A lot of you could see that before I even proved it, but I'm just telling you that's how we could go about proving that. Now, the reason why that's important is this. We know, let's start with the easy part. We know that the height of the triangle is B units. So if I go here, this length, B units tall. So to get there, I'm going to go nowhere on the x-axis. So my ordered pair is 0 on the x-axis, but I'm going to go up B units. Okay? So we've got B units away. That'll be point K. To do points J and L, I've got this length right here, which is a length of A. Well, if these are both equal, you know that this length would be 1/2 A, and that this length would be 1/2 A. Okay? Well, L, right here, this point, the x value is half of A. The y value doesn't go up or down. Okay? Going on the other side, we have J, which is 1/2 A away, and we're not going up or down. So that would be the ordered pair for those points right there, J, K, and L. Okay? Now, let's see if we can apply this to the next two problems where we're actually given the pictures, and you want to. So let me just review one thing. Some problems you want to put the vertex on the origin. Some problems you want to put the center of the figure on the y-axis, or even on the x-axis. Most of the time it's the y-axis. Okay. All right, let's go ahead and take a look at the next two problems here. And in these two, we don't have to come up with the pictures. Pictures are already there. My goodness, go down. All right, sorry that took so long. Okay. Now, what would be nice is if you could go ahead and fill in some of these things. I'm going to change this a little bit. I'm going to say, instead of saying this is an isosceles triangle, let's go ahead and say it's equilateral. Okay, equilateral triangle. Okay. So, if I'm working this out, I would look at this and say, hey, I know x is 0, 0. Okay, that was simple. To get to z, I'm going to go over A units, so this length is A units long, and it's going to be A, but we're not going to anywhere on the y-axis, so I'm going to do A0. Okay? So right now, we're pretty much almost done. We do have the hardest part of the problem to go yet, though. Okay? And since this is an isosceles or equilateral triangle, I know that dropping this line down perpendicular to the base cuts that base in half. How do I know that? By hypotenuse leg. Okay? So these two lengths are the same. So this length here, from here to here, where that line begins up there, is going to be 1/2 of A. Okay? And so I know that my x value here is going to be 1/2 of A. Okay, now that's the easy part, going over 1/2 A. The hard part is, what's this length right here? Before we can figure out that length, we can figure out this length here. All three of these sides, they're all a length of A. So if you think about it, we have two out of three sides of a right triangle. Well, how do we figure out that last side? Well, don't we do the Pythagorean theorem? Now, I'm going to be honest. If I was to give this type of problem to most of us as of right now, from what we know, we would get this problem wrong because of that fraction right there. You need to make sure that it's in parentheses, and we need to go ahead and square both of them. Okay? So if I take 1/2 times 1/2, that gives me 1/4. All right? Now from there, how do I get this guy over to the other side? Well, I'm going to subtract him. So if I subtract a fourth from both sides, remembering that this is 1, you end up with this. 1 minus a fourth is 3/4. Okay? And then we're going to square root both sides to get this question mark by itself. So if I do that, here's what we have. Is it going to work? Oh, for some reason, there we go. So we have 3/4 a squared. Now I will tell you this, we can simplify that, okay? To simplify that, here's what I would do. Question mark is equal to radical 3 over radical 4 and then radical a squared, okay? Now we've talked about this one earlier this year. If we simplify that, that just becomes an a. Question mark, okay? What's the square root of 4? Well, that just becomes 2. And so you could leave it like this, but it's a little bit confusing written like that. If I write it like this, which is the exact same thing, it makes a little bit more sense, okay? So this length right here is going to be 1/2 a radical 3, and those two values right there give me the ordered pair. I'm going to go over half a, I'm going to go up half a radical 3, okay? All right, now, excuse me. Let's take a look at the second one here. If we look at number 2, it says name the missing coordinates of the isosceles right triangle, okay? Now, on my screen right here, it's a little fuzzy. It looks like that's an A right there. So as I look at this, I'm going to put down that that length is A. Now I know that I'm not going anywhere on the y-axis, up or down, so this just becomes a 0. Okay? Now if it's a right isosceles triangle, there's your right angle, and these two sides have to be the congruent ones. So I know that this over here is also an A. Well, I'm not going anywhere on the x-axis, but I'm going straight up on the y-axis, A units. So it's going to be 0, comma A. Okay? The last part, B, that's the origin 0, 0. Okay? Now you may be having the question as of right now, why in the world do we plug all these values in? Well, the reason is because we want to be able to set forth a proof that uses the variables that any number could be applied to. Okay? So if I go ahead and take a look at that, let's take a look at, clear that off. Let's take a look at the next page. Right here, okay? All right, it says write a coordinate proof to show that a line segment joining the midpoints of two sides of a triangle are parallel to the third side of the triangle. This is a proof of what later we will refer to as the triangle midsegment theorem, okay? So on my coordinate grid, if I were to draw something out, I would do something like this. Maybe I'll make a point up here, a point down here, and then a point over here. And I'm just going to connect those three. Okay? Now I drew it kind of like an isosceles triangle, but we have no idea that it's an isosceles triangle. It can be any type of triangle. So I'm going to go ahead and do this. Let's say that this is going to be A, which is 0, 0. Let's say that this is B, which I'm going to label this length right here, I'm going to say is 2A, comma 0. Okay? The reason why I'm making it 2A is because I don't want any fractions left in it later on. I'll show you why here in a second. And then for part C, let's say that this is 2B, comma 2C, okay, which would mean over 2B units and up 2C units. Okay? Now, we then know, according to the given, that S is the midpoint of AC, and T is the midpoint of BC. And I want to mark it out accordingly. There and there. Okay? Now I'm going to tell you right now, there are two things that are true about this segment right here. This segment is called the mid segment. Okay, so I'm going to label that right now. ST equals mid segment of triangle ABC. Okay, makes sense, right? It's the midpoints that are being joined together, so we call it the mid segment. Okay, not meant to be super difficult there. Now there are two characteristics of this mid segment. One is that it's parallel to AB, and the second is that this length is going to be half the length of AB. Okay, so let's start by identifying what the ordered pair of S is going to have to be. Now, in order to find the ordered pair of S, you need to remember what your midpoint formula is. So it might be something that you want to use for your exam here in a couple of weeks. So midpoint formula, we'll just do this here, is going to be the average of the x's, 2 sub 1 over 2. It doesn't matter what the subsets are. Okay, and so if we can work that out, we can figure out what the ordered pair of those points are going to be. Okay, so and you want to write small here, guys, because I just want to make sure that we've got enough space. So in looking at this problem, to find S, I'm going to go ahead and find the midpoint of AB. So point S is going to be this. If I take the x values, 0 plus 2b, and part of the coordinate proof is showing this work right here. Okay, so you end up with B comma C. Okay, that's the ordered pair. If I divide 2b by 2, you get B, 2c by 2, you get C. Okay, point T is going to be this. Let's see here. I'll take 2a, since a comes before b, plus 2b over 2. And then if I go back to point B, 0 plus 2c. Now if I simplify this, I can divide both these by 2, so you're left with a plus b, and then this over here would just be c. Okay? So that's our ordered pair for both points S and T. Now, we are going to prove the second part. This is half the length of this. We're not going to prove that right now. But this length right here is parallel to this, and we're going to prove that. Now, you need to ask yourself, what formula should I use in order to prove the lines are parallel? And I hope you're thinking in your mind, I want to use the slope formula. Okay? That's what we want to use here. So, as we move on, how big of, let's make this bigger. Okay, I'm going to get rid of this here so that I can use more board to write with. So, there we go. All right, so we've got the ordered pair. How do we figure out if they're parallel or not? Well, the slope formula, if you remember, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So if I go ahead and take a look at AB, and I might want to just put a head in slope. All right. If we take the y values, we have 0 minus 0. And then it depends on which point you started with. Let's say I started with B, 0 minus 0. It would be 2a minus 0. Okay? If you started with A, it doesn't matter. You'd have 0 minus 2a. If I simplify this, in my case, it would be this. But in both of the cases, it's just a slope of 0. Okay? For ST, okay, I'm going to start with point T, and again, it doesn't matter which one you start with, but I'm going to do C minus C over a plus b minus b. So again, where I'm getting that is I'm going to go this minus this over this. Uh-oh. Not sure what that was. Okay, sorry about that. Over this minus this. Okay, so again, y minus y over x minus x. Okay, so if I work this out, c minus c, well that's just 0. No c's left. B minus b, well that's 0, so it's over a. And in this case, the slope is 0. Okay. Now how do you finish up the proof? We've proven it. They both have the same slopes. You still want to write what I would call like a summative assessment, a solution, a summation of what we've just done. So I'm going to say this. Therefore, AB is parallel to ST because they have the same slope. Okay, those lines are parallel because they have the same slope. All right. So there is one last proof. I know that's kind of a lot. There is one last proof that I would like to do with you just to make sure we've got this down. And so let's go down to the second proof down here, and let's take a look at what we have. Okay. All right, so on this last proof that I wanted to look at with you guys, it says here that we want to write a proof to show that the triangles are congruent. Okay. Now there's several different routes you can take here. You could do the distance formula for all three sides of this triangle here, and the distance formula of all three sides of that triangle, and actually prove the two triangles congruent. Okay. But I think an easier way, we always want to talk about what's easiest or what can be done fastest, is this. We already know that the vertical angles are congruent. So we'll state that in a little bit. But if I can prove that this length is congruent to this length, and this length is congruent to that length, we have side angle side. Now, instead of using the distance formula, let's go about this using the midpoint formula. If I can prove that the midpoint of BD is that point right there, and I can prove the midpoint of AC is this point right here, then I will know that this length equals this length, and this length equals this length, thus proving side angle side. Okay? So we've already got the midpoint formula that we've worked out. So if I go ahead and do this as a heading, we're going to work on midpoint first. If I do the midpoint of BD, okay, let's see here. I'm going to do something like this. B is X, D is A, and then the Y value is B plus 0. X plus X over 2, Y plus Y over 2. If I simplify that, we have X plus A over 2, comma, B over 2. Now what I want you to see is this X plus A, that's the same thing as A plus X. Okay? So as of right now, X is the midpoint of BD. All right? So I might do something like this to show what I've just marked out there. Okay. If I do the midpoint of AC, we'll start with C this time. X plus X over 2 and Y plus Y over 2. Okay. Okay, so again, I'm just taking the x value, x plus x over 2, b plus 0, y plus y over 2. This ends up showing us that we have a plus x over 2, and we have b over 2. Okay? And I would say something like this. You notice that you got the exact same point here with that one. So I'm going to say something like this. Okay? And I'm going to mark that out. And then to finish things up, I would maybe conclude it by saying something like this. All right? So that's a coordinate proof. It's in the coordinate plane. I've got my values. I just plug into my formulas to make sure that everything works out correctly. Now, you may need the distance formula on some of your homework problems concerning the coordinate proofs. So let me also give you that just to make sure we've got that down. Okay? So I hope that was easy enough to understand. I appreciate you paying attention and wish you the best luck. I will be checking both the previous 2 days' homework when you return, so good luck. Thanks and have a good day.